Yeah. Before I start up with showing you a demonstration of a power analyzer and the recorder, I would like to harp on a little bit about this demonstration kit. This kit basically mimics E-drive system, or you could say it mimics an inverter or an AC drive. There are two types of AC drives. One is the AC in and the AC out. The E-drives are basically one used at electric vehicles, are the DC in and the AC out. The DC in is a standard DC bus that is fed to the three-phase drive, AC drive, and output of this is the pulse width modulated AC out and the current, a sine wave current. Now, as you see, the motor here is the load for the drive, and you could see I have a variable frequency that I could move. Let's say I set this at 1500 RPM, I mean 1500 Hertz. Okay, so once I set this at 1500 Hertz, about 1.5 kilohertz, I could see the motor rotating at a particular speed, and you could load this using a load cell. There's a load resistor, so I load this on a higher load and I load this on a lower load, and every time the motor is loaded, the torque sensor picks up the torque and the RPM and sends a feedback to the power analyzer. So this is basically a test system that any person working on inverters, E-drives, batteries, DC to AC converters, DC-DC converters, AC to DC converters, motor manufacturers, motor test systems, and various other electric vehicle manufacturers and design people would require such a system. What we essentially do here is to check for its AC to DC conversion ability, your DC to AC inversion ability of the drive, and if to see if, study if the drive has any noise or so on and so forth, and also its output that is fed to the motor and its functionality and its load that the motor could take, if the motor has any slip or if the motor has any stalling or the motor is overloaded, underloaded, or so on and so forth. And hence we derive an efficiency between the DC-DC systems, DC-AC systems, AC to motor systems. So the efficiency of the drive, efficiency of the motor, and efficiency of the system can thus be configured and viewed on the power analyzer. Let me shift over to the power analyzer. What I have here, I have configured my input to, as I told you, this is a 6-channel power analyzer. So I could have a 3-phase input as the drive the input to the motor from the drive, and the DC input to the drive. Now I can configure this and I can call this as the pulse width modulated setup for the 3-phase, and I can call this as a DC. So I have configured this as the 3-phase pulse width modulated output of the drive and the DC in to the drive. Once I have done that, I have set my I range, I mean current range, and the voltage range, and thereby you could set up a configuration where we have a phase shift. This is the only power analyzer in the market right now that has a phase shift correction, which means when you have 3 phases, each phase has an accuracy by way of the current sensors we employ. This accuracy is something that we have to live with, but whereas the accuracy in the phase, so what I'm talking about is the phase between these 2 channels. The phase shift between these 2 channels has a kind of inaccuracy, and this inaccuracy is something that can be corrected using this phase shift function. And this phase shift function, either way, has been employed for the 3-phase system that we have connected right now, and this is employed for the 3-phase output. And this we have kept it off because it is not required for a DC, and then we could employ the same here. And once this is through, we have a auto range system, that we have update systems, and the THD that is required as per the functionality of this instrument. The THD can be either 1 over fundamental or 1 over total. And besides, there are three types of power calculation. I will come to this in later. It's three schools of thought. One is type 1, type 2 and type 3 are three different schools of thought, and finally you could arrive at a particular type of measurement depending on your application. Okay, and we have a motor here. Motor setup, I have a torque sensor there, like I have mentioned. We have this voltage range, 1 volt and 0.95 scaling of Newton meters. This motor has 6 poles and the motor pulses are 360. So once you set this up, we have an analog output for torque and a pulse output for speed, which is actually measurable here.